Welcome to Ask and Learn.
We have a 10-meter wire, out of which 5 meters is copper and the remaining 5 meters is aluminum. And the diameter of the wire is 1.4 millimeters, and the voltage across the wire is 85 millivolts. And the first thing we want to find is the total resistance of the two wires. So the resistance of the copper part and the resistance of the aluminum part. So first, our total is the resistance of the copper plus resistance of the aluminum. Now, from our formula, we know that resistance is resistivity times the length divided by the cross-sectional area of the wire. So it's going to be resistivity of copper times length of the copper divided by the area, and same for aluminum, AL divided by AL. Now, since the length of the two sections is the same, they're both 5 meters each, and also the cross-sectional area is also going to be the same since the diameter of both sections are the same. So we can factor that out. I'll just put that down as L and A. So this is L over A times the resistivity of copper plus the resistivity of aluminum. Okay. And I know the length, that's 5 meters. I know the diameter, and from the diameter I can find the cross-sectional area, which I will do now. So diameter is 1.4 millimeters. This means that the radius is going to be 0.7 millimeter. So diameter divided by 2 is radius. And so cross-sectional area is pi r squared, which is equal to pi times 0.49, which comes to let's see, 1.54. Okay. And so I have 5 over 1.54 times, and I have my resistivity values listed out over here. So this is going to be 1.68 plus 2.65 times 10 to the negative 8. So one thing I forgot, the area, the value of the cross-sectional area here is in terms of millimeters, so millimeter square. So the value over here, it's not just going to be 1.54, it's going to be 1.54 times 10 to the negative 6. So if I simplify this, I will get a value of 0.1406 ohms. So that's the total resistance of the wire as a whole. The next thing that's asked is what is the current through the wire? So that's simple. We know the voltage and we also know the total resistance. So I is going to be V over R, and that's going to be 85 times 10 to the negative 3 divided by 0.1406. And if I evaluate this, I get 604.55 milliamps. So that's the current through the wire. And the last part asks, what are the voltages across the aluminum part and across the copper part? So we know the current, which is 600. I'll just write this in terms of amps actually. So 0.604 amps. We know the we're looking for the voltage across each section and copper. And the idea here is to consider the individual resistances of each section of the wire. So we will need resistance of the aluminum wire and resistance of the copper wire. And this can be calculated by using the resistivity formula again. So I'll do copper first. This is just resistivity of copper times the length divided by the cross-sectional area. Now for copper, it's 1.68 times 10 to the negative 8. And the length is going to be 5 meters. And the cross-sectional area is going to be 1.54 times 10 to the negative 6. And similarly for aluminum, it's going to be 2.65 times 10 to the negative 8 times 5 divided by 1.54 times 10 to the negative 6. So after evaluating the resistances of each of the sections, I get the values. So it's 0.054 ohms for the section of copper wire, and 0.086 ohms for the aluminum. And I know the current, and based on this, I can find the voltages of each of the sections. So I'll say voltage of aluminum equals I times the resistance of aluminum. So that's going to be 0.604 times 0.086, and voltage of copper is going to be the current times resistance of copper, which is 0.604 times 0.054. So after evaluating these expressions, I get the voltage of aluminum to be 0.052 volts or 52 millivolts, and the voltage of copper to be 0.033 volts or 33 millivolts.